Welcome you all in the 14th lecture of Electronics Measurement and Instrumentation. This is the fourth lecture of CRO. In previous lecture I have discussed the front panel control of the CRO, what are the different characteristics we can measure of an electrical signal, how we can test different components. There are a fixed pattern, standard pattern in CRO, and by comparing that pattern we can see whether our component is working or not, like diode, transistor, FET and other component. And then I have also discussed about the cathode ray tube, which is known as heart of the CRO. In this lecture I will discuss the block diagram of the CRO, means except the CRT we will discuss all the blocks which are in the CRO. So, CRO consists of CRT, cathode ray tube, vertical deflection system, horizontal deflection system, time based generator, trigger circuit and power supply. As we can see in the figure, this is the basic diagram of a CRO. This CRO consists of one vertical amplifier and one is the time based generator, that is the horizontal amplifier, vertical section and horizontal section. This is basically not a vertical amplifier, it is vertical deflection system and horizontal deflection system. So, if we see the vertical deflection system, the input signal is fed to the Y amplifier vertical deflection system through the probe. So, we know that the characteristic of the probe is that it will, if it is an attenuator, then it will attenuate all the signal by same times, means the amplification factor or the attenuation factor of the probes are same for all the frequency, whether we are measuring DC voltage or we are measuring AC voltage of high frequency, low frequency, it should provide the same amplitude for all the signals. So, the input signal is provided by the probe to the Y deflection system, that is the vertical deflection system, and this vertical deflection system we can control the position of the waveform on the screen, means by providing a DC biasing here the DC biasing, and by varying the DC biasing we can change the position of the waveform in the Y direction. And this is the knob which selects the volts per division. So, by selecting this knob we can change the volt per division. If the amplitude of the signal is very high, then we will keep this volt per division at high voltage, so that it can, the waveform can be displayed on the screen. Then the output of Y amplifier is fed to the Y plate. Then in general, when the leading edge of the signal, when the signal appears at the Y plate, the unknown signal, then the leading edge of that signal is used to trigger the time based generator circuit. So, when this signal is triggering the time based generator circuit start generating the time based waveform, that is known as sawtooth waveform. It is known as sawtooth waveform because its shape is like a tooth of the saw. Then it will generate this, and this voltage is fed to the horizontal deflection plate, and this horizontal deflection plate basically controls the movement of electron in x direction, and they are placed vertically. And then there are two controls in the time based generator, this x position and time per division. X position means there is a DC voltage, that DC voltage is applied, and so we can move the waveform when this DC voltage is applied, we can move the waveform in the right hand side, and by this knob we can change the time per division. So, this is the main circuit of the CRO. Then this is the extended diagram of the CRO, block diagram of a CRO. Here we can see that if we want to measure input signal, then if the amplitude of the input signal is sufficient, it can directly displayed on the screen, then it is directly fed to the Y deflection plate. But if it required to amplify, then it is fed through the amplifier. If it is required to attenuated, then it is fed through the probe. Probes are available where it can attenuate the signal by 10 times or by 100 times. Then in horizontal deflection plate also there is a external circuit and there is a internal sink circuit. So, if horizontal plates, if we want to synchronize the input signal by putting a portion of the input signal to the time based generator circuit, then it will, this sink circuit is kept at internal position here, and at that time we see the vertical deflection, vertical amplifier is connected with the sink amplifier, and this sink amplifier will is fed to the sawtooth sweep generator. So, when the leading edge of the input signal appears, unknown signal appears, the sink circuit will will switch on this sawtooth sweep generator, and this sawtooth sweep generator will connect it with the horizontal amplifier, and then it is fed to the horizontal deflection plate. There is a calibration circuit. So, before starting whether our CRO is working properly or not, a calibration oscillator is there. So, and there is a pin at which we can connect this signal and we can calibrate the signal, calibrate the CRO. Then we can see there is a blanking circuit. So, what is the function of horizontal amplifier or horizontal section is to move the electron beam in the horizontal direction, in the x direction. So, when the beam moves, when the electron beam moves from left to right, then it traces the pattern, whatever input signal we have applied, it traces the pattern, but when it reaches at the extreme right position, then what will happen, it has to come back to the left position so that it can trace again the signal. But when it is reaching at the right position, then if it will get back to the left position, and at that time the signal will be traced, then there is a overlapping and then we will not able to see the signal. Because of that, there is a blanking pulse applied to the cathode. So, at that time the cathode will not emit any electron. For this purpose, when electron beam moves from extreme right to left, the blanking circuit applies a blanking input signal to the cathode. Okay, so, this is the, again intensity is controlled by the control gate potential, and similarly the focus is controlled by the focusing pattern. Then vertical deflection plate. The vertical deflection plate has following circuits. First, and what is the purpose of the vertical deflection section? First is to amplify and reproduce the input signal. The amplifier must have good fidelity, means it can amplify the input signal within the limit of its bandwidth and without affecting the amplitude, frequency and phase of the signal. Second, it has to isolate the CRT from the input signal, means the input signal will not affect the CRT, and the second thing, the CRT will not affect the input signal. So, it provide an isolation between the CRT and the input signal. So, for this purpose we know we are using buffer circuits, that buffer circuit may be made up of op-amp, or we can use the FET amplifier, common source FET amplifier, common emitter transistor amplifier. Then it must have provision for different mode of operation. So, vertical deflection system, if we see, is made up of probes, then input selector, and then the input attenuator or the amplifier, whatever we require. If the amplitude is high, then generally the attenuators are inside the probe, but if attenuator is required, then we will pass the signal from the input attenuator and then amplifier, and the output of the amplifier is fed to the vertical deflection plate. This is the internal circuit of the vertical amplifier. So, the purpose of vertical amplifier is to first that the signal will not affect the CRT, and the second thing is that the signal has strength to drive the CRT vertical plates. So, to amplify the signal, a preamplifier is used. So, here the preamplifier is used. Here it is made up of cathode source follower FET circuit, and this is op-amp, positive feedback op-amp. So, it acts as a buffer circuit. Then since the output of this is fed to the push-pull amplifier, the output amplifier is push-pull amplifier. So, for push pull amplifier we need two signals, same amplitude signal, but the phase inverted signal. So, a phase inverter circuit is there. Phase inverter circuit will produce two signal which is 180 degree out of phase. Then this signal is amplified by the driver amplifier, and it is provide the required input voltage to drive the push pull output amplifier. This push pull output amplifier supplies the deflecting voltage to the deflecting plate. So, this is all about the vertical deflection section. Now, the horizontal section. Horizontal deflection system consists of sweep generator or time based generator, the horizontal amplifier, the trigger circuit. Trigger circuit may be of triggered sweep from the unknown input signal, or it is a free running sweep circuit. So, this is the circuit diagram of vertical deflection system. So, we can see that the vertical deflection system has 3 point, one is external, internal or line. So, this power supply, this circuit, that is the trigger circuit, it may be internally connected. Internally connected means it is connected with the unknown signals input, or we can put it at the external position. When it is at the external mode, then it means ki we can apply external triggering pulses for the operation of this circuit, and we can also connect it with the line frequency. So, if low frequency signals are to be measured, we can put this Smith trigger at the line position, and it is connected to the power supply. Then when this triggering circuit is at internal position, then the leading edge of the vertical amplifier signal is fed to this trigger circuit. So, trigger circuit consists of two parts, one is the Schmitt trigger, another is the RC differentiator. So, Schmitt trigger function is to produce a square waveform. Then this RC differentiator, basically what it does, it just there is a RC combination. So, it will convert this wide band signal, signal in a very spike signal. So, it is converted into spike signal, and that spike signal is fed to the sweep generator. When this signal appears at the sweep generator will produce sawtooth wave signals like this way. This is the trace period and this is the flyback period. So, during trace period it will the input signal is traced at the CRT screen, and during this flyback period the electron beam will move from extreme right to left position. Then it is amplified by the horizontal amplifier and fed to the CRT. Now, this is the horizontal free running sweep generator circuit. So, in free running sweep generator circuit we are using capacitor and JFET transistor. So, when this input supply VBB is applied here, then capacitor C will start charging. We can see here it will start charging, and when the the voltage at capacitor C is more than the voltage that is required to switch on the JFET, then when this VC voltage is equivalent to the voltage that is required to switch on the JFET, at that time the JFET will switch on, and when it is switch on, then it will draw current from the capacitor, and when it is drawing capacitor current, then capacitor will discharge. So, we can see when this is on, the capacitor will discharge. Then when it will reach certain value, then again the capacitor will charge with the VV voltage, and so this type of, due to charging and discharging of current, a free running sweep is generated. So, this is the free running sweep, and if this is, we can see here that a spot is moving in the x direction, and after this there is a flyback, and in flyback it will return to the y position. Now, when we apply the signal, input signal at the vertical plate, vertical deflection system, in vertical deflection system the signal is passed through the vertical plate, and it is fed to the it is passed through the vertical amplifier, and then the signal is directly fed to the vertical deflection plates. But in horizontal direction we can see that the signal is pass through the sinc circuit. In previous we can see that the signal is passed through the trigger circuit, then through the sweep generator circuit, then horizontal amplifier, then it reaches to the horizontal deflection plate. So, it requires some time. So, if we directly feed the vertical amplifier to the CRT and the signal in the horizontal signal is travelling in such a path, then what will happen? These two signals will not synchronized. So, here a delay line is placed. So, this delay line basically provide a delay of 200 nanosecond. So, it adds a delay of 200 nanosecond to the vertical deflection trigger, so that both the signal, the horizontal deflection signal and the vertical signal both appear simultaneously on the screen. So, for this purpose, after the pre-amplifier and main amplifier of the vertical deflection system here, then the delay line is provided, and because this signal when it travels it takes approximately 200 nanosecond. So, 200 nanoseconds are provided, the delay is provided in the vertical section. Hence, the time based signal precedes the vertical signal in appearing at horizontal deflection plates, then the vertical signal appears at the vertical deflection plates, thus serving the purpose of delaying the vertical signal. Now, delay lines are of two types. One is lumped parameter delay line and second is distributed parameter delay lines. So, lumped parameter delay lines consist of symmetrical LC network. In LC network, we can cascade the LC network as shown in figure, and by this network can be used as a delay line. We know the delay time of this network is given by Td is equal to 1 by pi Fc, and that is equivalent to root Lc, and that is the delay time provided by a single Lc combination. Then if there is an n number of combinations, then this total delay is equal to n into Td, where n is the number of cascaded sections. So, this is the lumped parameter delay line. The second is the distributed parameter delay line. In distributed parameter delay line, we basically use the coaxial cables as a distributed parameter delay line. So, in coaxial cable, the this center conductor is replaced by the continuous coil of wire wound on a flexible inner core in the form of hexel. So, distributed delay parameter delay line is basically a coaxial cable in which the conductor is replaced by the continuous coil of the wire. So, the inductance of the delay line is offered by the inner coil. The inductance can be increased by increasing the winding of the coil. The capacitance of the delay line is provided by the two axial cylinders separated by the polyethylene dielectrics. So, using thinner dielectric, the capacitance can be increased. The parameter of the helical high impedance delay lines are typically 100 ohm of Z naught and 180 nanosecond per meter delay time is provided. So, this delay time is advantageous over the lumped parameter delay time, as it requires a very small space and it does not require a very critical adjustment. Now, sinc selector circuit. So, in sinc selector circuit we need know that there are three modes. One is external mode, internal mode and the line mode. So, here it is three mode: external mode, internal mode and line mode. So, for line mode we have to directly provide this with the main line frequency, that is 50 hertz frequency. So, we can connect it with this terminal. In external mode we can connect it with any external signal. Suppose we want to measure the relationship between phase difference between two signals, then we know that one signal is applied at the vertical deflection plate, another signal is applied at the horizontal deflection plate. So, at that time we will keep it at the external position and external signal is applied over here. Then it is fed to the comparator. Comparator will, there is a voltage division circuit. So, the comparator compares whether the external input is higher than that or not. So, as we know, the selector has 3 position, internal, external, line. Therefore, the horizontal sweep can be synchronized with the signal coming from any of the 3 sources through the comparator. The comparator gives an output when trigger input signal exceeds a particular level. So, the function of comparator is to compare both 2 signals and it will give an output when it reaches, when both the signals are same. So, or when the one signal increases with the other signal. So, when the trigger input signal exceeds a particular value as set by the trigger level control, a schematic trigger that follow the comparator generates negative pulse each time when the comparator's output crosses the trigger level. That triggers the sweep generator to start the new sweep. So, this is the function of a trigger circuit. Thank you all from my side.